Welcome to our project on water-sensitive urban design. We are Recover Consultancy, comprising 8 Imperial College civil engineering undergraduates. Our academic supervisors for this project are Dr. Matthew Graham and Professor Nigel Graham. What is water-sensitive urban design? It is the process of integrating water cycle management with the built environment through planning and urban design. Instead of designing the water infrastructure separately, it is included at an early stage of the design process. Water-sensitive urban design can bring about many benefits. With proper planning, it can mitigate flooding risks in the region, overcome water shortage in the community, reduce water costs for the users, promote growth, and make the environment more livable.
Our aim is to design a water-sensitive urban development for 10,000 people in the southeast of England. We are to focus on the water infrastructure and integrate it into the landscape. Moreover, the profitability of the investment has to be ensured. Furthermore, the requirements of different stakeholders, such as the Environmental Agency, local authorities, a local environmental interest group, and the Water and Sewerage Company have to be considered. These requirements set the main constraints for the development. Our vision is to deliver a development that will be easily marketable in order to ensure a reasonable profit margin for our clients. We commit to develop a water system that minimises the impact on the existing water cycle, and finally, we want to create a community that people will enjoy living in.
In order to gain an initial understanding of the design requirements, we separated the analysis of environmental infrastructure into 3 different topics: water provision, surface water management, and wastewater management. We also consider the impact of climate change on the water cycle of the development. In the UK, the domestic water consumption is on average 160 litres per day per capita. This pie chart shows the distribution of how this water is used, of which 65% requires potable water and 35% can be non-potable. Our aim is to reduce the potable water consumption from 106 to 80 litres per day per capita using water-efficient appliances and recycling systems. Potable water is water that is safe enough for consumption. We aim to provide potable water from either groundwater extraction, from mains, or rainwater harvesting. After analysing all the options, we decided that groundwater is the most economical and environmental-friendly option.
Our site is located above a confined aquifer, which is naturally recharged at the northwestern outcrop only. The aquifer will also need to be artificially recharged after groundwater is extracted to maintain equilibrium and reduce the impact on the water cycle. Artificial recharge will be achieved through injection wells. Sustainable urban drainage system helps control and manage the surface water runoff. They can reduce runoff volumes or attenuate peak flows in order to reduce the risk of pluvial flooding. The most preferable option is to prevent the rainfall from going into the drainage system rather than controlling the runoff later on. Sets are usually combined in treatment trains, for example, harvesting rainwater from the roofs into storage tanks, then draining it in vegetated trenches instead of stormwater sewers, and finally leading it into a wetland or pond. Alternatively, pervious pavements can collect rainwater and lead it to detention basins in case of heavy rainfalls.
Generally, domestic wastewater can be divided into 2 categories: grey water from bath, laundry services, and etc., and black water from toilet flushing and kitchen sinks. Recycling of grey water is preferable, as black water requires more extensive treatment. A decentralized grey water treatment system will reduce water consumption dramatically. 3 options have been considered for the treatment of black water. The first option is to direct wastewater to the existing sewer trunk. The second option is to construct an on-site small-scale wastewater treatment plant, and the third is to build 1 or several constructed wetlands. This design shows how we imagine the development by integrating different water management strategies. We will use this design as a guideline to evolve our ideas and aims to minimize the impact of the development on the local water cycle. However, this design is highly dependent on the location choice.
We have provided the client with 5 potential areas for development and are currently analyzing each one by considering the topography, distance to existing water infrastructure, and the local environment. At the moment, we consider sites 1 and 2 as the best locations for further development. It is key that we decide who we envision living in our development. This will affect the direction we take in terms of housing sizes, floor plans, housing prices, amenities, and marketing plans. Our targeted customers shall focus on young families, retirees, as well as people seeking green and non-urban style lives. We plan to design housings that blends in well with the natural landscape and provide sustainable and contemporary living conditions to our customers. This will be achieved via using timber frame structures, stones, and glass as our main construction materials. Interchangeable floor plans will also provide a flexible solution to variable demand.
The overall risk of the development may be considered as medium to high. The organization's lowest risk appetite relates to health and safety issues as well as to environmental and conservation concerns. More risk, however, is taken towards the financial elements of the development. This is due to the innovative character of the design. Health and safety is a paramount and integral aspect of our development. We aim to have 0 fatalities throughout the construction process and reduce the risk of fatalities and injuries throughout the design life. Incorporating these risks at a very early stage in designing can save both time and money in the future. The initial meetings with our clients have shown that we are working in the right direction. The next stage of the design process will involve developing iterative multi-criteria assessments to further narrow down the options in order to produce the optimal solution of our project.
Thank you for watching our development presentation. Special thanks to our academic supervisors, Dr. Matthew Greetham and Professor Nigel Graham. And thank you to our module coordinator, Dr. Andrew Phillips and Ms. Rebecca Nasons. Follow us on Twitter, Instagram, and our blog, recoverconsultancy.wordpress.com for more future updates.